Hi everyone, thank you for joining today. Thank you for joining us in today's webinar. Today's webinar is all about our reliability services, what they entail, and how they can be of benefit to your business. So today's webinar is in line with our company strategy: advise, apply, advance. Advise, anticipating customer needs. Apply, delivering innovative products and solutions. Advance, creating value with technical and advanced services. Today's webinar is all about how we can improve your productivity through improved reliability. With our many years expertise in engineering solutions, we have come up with some key areas we would like to present today that could help extend the service life of your critical assets. So to start with some introductions from our side, my name's Jason Tweedy and I am the head of UK Reliability Services for Brammer, Hickman. Started out my working life as an apprentice for Audi as a technician. I've currently been with Brammer, Hickman for 10 years. Started out with Brammer as an insight support and I've worked my way up. I'm now currently qualified and experienced to BINDT and SNT standards in vibration analysis and thermography. And I'm currently part of Rubix's European team on innovation and technical development of technologies relevant to today.
Good morning, everyone. My name is Antony. I'm the Group Technical Director for PCMEng Group. We are the Brammer reliability partner in the UK. So a bit about my background. I'm originally from an electromechanical background in the repair industry. I actually started with Dowding and Mills some 22 years ago, which seems like yesterday. Been involved globally with various different clients, multiple industries, different maintenance and reliability techniques over the years. I'm also part of the British Institute of Non-Destructive Testing group committees for general condition monitoring, where we're currently developing a new training standard for general condition monitoring, as well as the vibration analysis working group, where we look at examination criteria and so on. And I've recently become part of a BSI standards committee for 2 vibration shock standards for ISO standard development.
So today's approach in this presentation is essentially to give you an overview of reliability services, why we perform these services, and the potential benefits of these to your business. Over to you, Antony.
Thanks, Jason. So the first question is, why have reliability services? And the easiest way, and I'm sure many of you have seen a similar screen to this before, similar diagram, is to look at the PF curve. Now, the PF curve is the potential failure to functional failure curve, and it's the easiest way to demonstrate how equipment fails, the typical timescales, but then also, as you can see on screen, the various tools and techniques that can be applied to allow as early a detection of those failure modes as possible, to allow maintenance remedial actions to be planned effectively. Now, assets and components, as you can see from the shape of the graph, they do not fail in a linear fashion. We cannot sort of assess from a one-shot reading that a bearing will have 2 weeks life remaining or whatever the interval may be. There are a lot of factors that have a significant effect on the failure rates, the failure propagation, between that problem detection through to the functional failure point. And the main areas that affect that are speed, so different speeds. Obviously, the higher the speed, typically the faster the rate of failure on particular assets. Increased load. So if the load increases, typically the opportunity before functional failure, the time window reduces. Maintenance quality, which is a big one, and environmental conditions. Now, coming back to the maintenance quality, one of the areas in days gone by, lubrication, for example, was always deemed as the lowest rung on the ladder of maintenance, when in reality it is one of the most important key elements within maintenance of any asset. You get the lubrication wrong, potentially you will significantly reduce the life expectancy of that particular asset. Now, functional failure could be that a pump no longer provides the required output, as an example. It does not necessarily mean that the asset has blown itself into 1,000 pieces. So it could be that a pump's designed to perform at 50 litres per hour, and now it's only performing at 10. Therefore, that unit has functionally failed. And it's about the correct application of the correct technology at the correct time to assess those conditions, detect those failure modes, to ensure that there is the best return on investment for your business. Now, what we always find, and the PF curve on screen does demonstrate that, is the window of opportunity by application of multiple technologies. There is no one hard and fast rule that is correct as a detection technique for all failure modes. And indeed, the more applications of the multiple technologies that you can introduce to an asset monitoring cycle, that provides the best opportunity to understand where that asset exists within its life cycle. Now, in terms of the definition, as if we say, of CBM, a lot of people get this wrong. So a lot of people call it condition-based monitoring, which is incorrect. So it's actually condition-based maintenance. So we're talking about maintenance on condition. Now, if you regard CBM as a toolbox, condition monitoring, performance monitoring, standard PPM checks, they all technically form part of a CBM toolbox as such. So that robust CBM strategy can form multiple assets and different tools and techniques that form within that. It's not just about the technology, it's as much about human sensors, what are the performance criteria that's being monitored by certain systems. So where CBM is selected as a strategy, we want to monitor and maintain based on condition instead of just on a time basis. Then there's key elements that can be experienced from a client perspective as well. So we have increased asset reliability. We reduce the maintenance spend as a potential because we're able to plan and optimize repairs. We're able to get spares on just-in-time delivery rather than keeping a huge portfolio of spares in the stores. So we can look at the schedules in place to optimize that as much as possible. Now, this leads to potential increase in productivity because the availability would increase. We're reducing that downtime. We're trying to reduce that interval for maintenance and that mean time to repair. We're trying to reduce the costly failures and make it so that things are small, concise changes and remedial actions to bring that unit back to standard. Now, there is not one hard and fast rule, to reiterate that point. So we look for a tailored solution. So it really depends on your business aims and goals. If you have a focus from the accountants within the business, because a lot of businesses are run by accountants now, where you're looking at the goal is we want to reduce maintenance spend by 5%, for example. We have to then understand what are the processes in place, what are the methods of maintenance, what are the budgets, what can be invested in achieving that change of 5%. Is it actually a focus on maintenance, or does it need to be a focus on operational changeovers or whatever's required in your particular application? Now, the same business can run 2 different sites. Indeed, you can have 10 of the same assets on the same site. They can all operate in a different way, and therefore you need to apply CBM techniques and general maintenance strategies in a completely different way. So as much as we provide the data, and the data provides a method of data-driven decisions, as opposed to being subjective and opinionated, it's more around the data to make those decisions in the first place. So there is not one hard and fast rule. You cannot buy something off the shelf and it gives all the answers. Unfortunately, it doesn't work like that. I wish it did, but it doesn't.
Thank you, Anthony. So Brammer and Hickman decided to go into partnership with the PCMS Group for several reasons. The main benefit for all customers is providing a reliable CBM service tied into a fast, effective and high quality repair service. Essentially, if we find something wrong with your equipment, we are able to remove it, inspect it, repair it and return it quickly, and even reinstall correctly if you require. It also means between us, we can give you full UK coverage staff-wise for both repairs and CBM, boasting 40+ engineers out on the road with another 18 behind the scenes repairing your equipment. This also includes hydraulics. PCMS also have their own independent oil laboratory. meaning market-leading reports with customer-favourable pricing. We are, between us, able to provide accredited training in all aspects of reliability, including CBM data collection tools, analysis, and installation maintenance techniques, and are also a BINDT approved training centre. On the back of all of this, we can bring in our Rubik's category specialists to look into any long-term issues or problems that require specialist attention. Back to you, Anthony.
Thank you. So as you can see on screen, there's a number of icons on screen, and this was an exercise that we at PCMS look to achieve, to try and demonstrate to our clients and to Brammer's clients on what we can provide. This is just a small section. So we do have the condition monitoring elements on screen. We have the asset insight tools, where it's multi-technology approaches and specific asset types that and structures and so on that can be assessed. And then on to the remote services, where we can provide the level of remote services that a lot of our clients are now looking for, particularly during this COVID situation over the last 12 months. So whether you're looking at new machines or newly overhauled machines, where you're making sure that assets are in a good condition before going back into service, or you're having aging assets. So PCMS and Brammer have the tools and technologies available to understand the condition of the machines and also the structures as well that these machines sit on. So from that perspective, again, there is not one hard and fast rule. You don't need significant amounts of historical information to make an asset assessment. We can perform things such as one-off health checks and so on to give an indication of the condition of those assets. But just sort of delving into some real specific details and applications. So diesel engine checks that you'll see on screen. Diesel engines and reciprocating machinery, so reciprocating compressors in particular, are notoriously difficult to monitor from a vibration perspective. So this is just some examples of where we've taken it to the next level with the application of off-the-shelf techniques as well. So utilising PeakView technology from Emerson, we can assess the condition of an engine, looking at each cylinder in isolation, looking at the valve operations, identify problems, real specific areas around fueling, cylinder, and so on. Now, if you don't have diesel engines and it's not of interest, it's more around the application. It's quite a complex application. We've designed a technique using off-the-shelf methods to develop a method of non-invasive assessment of the condition of those units, and that includes multiple technologies. Next one, noise surveys. So whether it could be part of a health and safety inspection, or it could be an asset acceptance or a factory exit approval test, where noise surveys, whether it be airborne or structural noise against ISO standards, may well be of significant interest and concern, and is required to achieve certification for that unit to go into service. So that utilises calibrated and ISO accredited equipment with qualified personnel to carry out that assessment. One of the other areas, again, we all know condition monitoring and the application of the techniques, a development, and many will have seen things around LinkedIn and so on to do with this, around operation deflection shape and also video deflection, using slow motion video capture to assess, using high speed video capture techniques with really high frame rates, to assess structural insecurities, resonant problems, and confirm misalignment issues. One of the things with vibration, there's an element of training, and as Jason will come on with the thermography, a picture or a video can explain things far faster than it can for a detailed vibration report. It's not something that replaces vibration, it just allows a visualization technique to understand exactly where structural repairs and reinforcements need to be within particular structures. We'll come on to a case history later on. So from vibration analysis perspective, essentially machines talk. So if you imagine you go on holiday to Spain or France, can you order a beer? That's the most important thing. So when we're talking about vibration, we're applying a particular tool that allows us to understand and decipher the signals, the messages, the verbiage that that particular machine is giving off. What are the patterns? Every fault within a rotating piece of equipment produces a specific vibration signature. So it could be imbalance, it could be misalignment, it could be looseness, it could be a bearing fault, and we can get down to specific areas where we can pick up outer race defects, inner race defects. As long as we know the shaft speed and the bearing type, we can be 99% certain of how severe a bearing problem is to give realistic recommendations to put corrective actions in place. Now, we utilise the latest data collectors from PCMS and Brammer's perspective, and we can recognise these patterns and identify the cause and, more importantly, the severity, so that we can be realistic with how long has this unit got before remedial action is required. Now, most of the time, and this is what I say to a lot of our clients, yes, we have all the tools and techniques to carry out some quite in-depth assessments, but more than 90% of the output from a lot of our reports and analysis are actually related to the basics of maintenance. Could be insufficient lubrication, could be imbalance problems where a fan needs to be cleaned. It could be that the machine setup from a misalignment perspective is incorrect. Therefore, it's increasing the stress on the machine and reducing the overall life expectancy within that asset life cycle. So most of the time, that sort of 90%, we're picking up things that actually highlight that is a failing or a misconception within the existing maintenance regime and application. Now, these actions really increase the asset life. Once the recommendations are in place, you would then carry out the actions. We would then retest that particular asset to confirm, were we correct? So there's an element of continuous improvement within this as well, and more importantly, collaboration as well. Now, from a high level assessment perspective, peak view and envelope techniques are the typical areas where rolling element bearing faults, for example, can be detected. And we've got several case studies between both PCMS and Brammer where we can detect bearing faults anything up to a year in advance. Bearing in mind what I said around the PF curve, that's highly dependent on the speed, the load, the maintenance characteristics, the environmental conditions that particular asset or component operates within. Now, we utilize the regular data collection techniques to really set the alarms and make sure that we can utilize the trends effectively, so that we can provide you with the best indication of how long we have to carry out these remedial actions to prevent the failure. So we can try and build that within where possible to prevent any further downtime, any additional downtime, and therefore increase your availability of that particular asset. Now, most of the vibration analysis that we provide and that Brammer provide is done on a routine basis, but we can also carry out one-off health checks, as I mentioned earlier, where we can utilize against ISO standards, or we have thousands of assets that we monitor where we can use statistical analysis, knowledge and experience of our PCN ISO accredited engineers, where we can provide third-party support also for warranty disputes and any acceptance tests. So we can act as a complete independent from that perspective. Now, whatever the size of the business or the number of assets, it's flexibility. There is not one size fits all, as I've mentioned several times. Now, it's whatever is correct for your particular business model, for your business needs. What are the short, medium, and long-term goals? Now, a lot of the clients that we work with may well start off with a fully outsourced program where we provide the engineering expertise, where we provide on-site services, we provide the data collection, the analysis, the comprehensive reports, and any management expertise that come with it, as well, as you can see on screen with some of the graphs from our Amiga system. Now, a lot of our clients want to move towards a degree of self-sufficiency, so wireless techniques are now coming to the fore. Online systems are still available also, but also handheld systems are now become more accessible to people at site level, so that there is a degree of the want and the requirement for self-sufficiency. So the next step in that process, moving from outsourced to a hybrid approach, is an element of where we may still provide some routine services on site, but some of the data collection is carried out by you guys, your teams on site, as you develop your reliability teams and so on. Now, we can provide the necessary training and expertise and technical support that comes with that to provide you with the best opportunity to leverage the benefits from that as an approach, with a view that self-sufficiency may be the next step, where we may be just a supply chain, we provide the training and then just the technical support. We're there on hand with our remote services as required to provide the assistance as and when needed. Now, we've supported several clients through this journey, which can take several years. And it depends on the level of skill available on site, the amount of time and resource that is available. Could come down to budgets as well, but it depends also on the business objectives around what are the CapEx and OpEx requirements within that maintenance and operational setting. Now, for inaccessible and critical machines, I've already mentioned, there's the wireless systems now are coming down to a price where they are accessible to multiple clients, and the capabilities that exist within a lot of the wireless systems now are very similar to online and high-level handheld systems. So there's a lot of systems that are available at quite a good price point now that become a possibility within your maintenance setting. Now, just an example of the power of the data and the approach that we provide. So this is a combined PCMS and Brammer client. It's a major UK building product manufacturer. They've used one of our competitors for a long period, and this is not about poo-pooing any competitors, by the way. That's certainly not in our remit. This is about a client that was in need. So they had an existing supplier. They experienced two major failures, one just before Christmas and one between Christmas and New Year. The same fan, as it was the same failure mode. Now, we've all experienced the 3 o'clock in the morning call outs or the Christmas Eve call outs. We don't want to be in that position. Our job really is to remove the pain and the burden of that, to make sure that that doesn't happen again within your operation and production settings. So from our perspective, we got a bit of background on this. There was a recent data collection and analysis from the incumbent, didn't show any issues, but the client had concerns because there was a noise, as he described it, from the fan, and he could experience the vibration just by touch and feel. Again, back to the human senses, which are very important. So we were asked to attend with Brammer to assess and complete a bit of a health check on this fan, and also to fit a temporary wireless monitoring solution, because the concern was that changes within the production setting, so air temperature differences, this was also a variable speed fan. So as the variable speed changed, the vibration was noticeably different through different cycles. So we carried out an initial health check, and the things that we found were quite significant. So the first step, we found a major motor drive and lubrication issue. Now, this was a brand new motor that was fitted after the failure, so it had only been in service about 3 or 4 weeks. So we highlighted on the motor drive end a significant bearing defect in the vibration signature. So that's slightly concerning for 2 reasons. A, the unit is in operation, we're at risk of failure again. But B, we've got a problem potentially with the way that the motors are stored within the stores as a spares holding capacity. So we worked with the maintenance team to understand and assess the lubrication volumes. We solved the problem whilst on site. We also detected a major misalignment condition across the pulleys. It may not be particularly clear on screen, but you may be able to see the laser line on the left image. The pulleys were 30 millimeters offset misalignment. One of the worst I've ever seen. So we corrected the alignment and the belt tension whilst on site. And we also carried out a full operation deflection shape model, which determined we've got a major structural weakness, as you can see from the animation. The bit that's flapping around is actually the motor end, which is where the majority of the vibration was being detected. And we highlighted, we tuned the natural frequency by adding additional mass. I'll not explain how we added mass, but I'm sure you can imagine. But it allowed the client to drive that fan through to a maintenance period for a major overhaul. So just one example there. Jason.
Thanks, Anthony. So moving on to air leaks. Air leaks are one of the biggest recoverable costs to industry. The issue being that most sites do not recognise the connection between air leaks and high air usage, and the relative costs. Compressor usage, as you can see, makes up the biggest cost of a compressor's life. Going with UK averages for compressor costs and leakages, we go off what is called the 30-30 model. So, an example UK business has a £400,000 electricity bill, of which 30% of this is the normal percentage to power your compressors. In this instance, works out about £130,000. Of this number, the UK average for air leaks is between 30 and 35%, can reach as high as 40. In this instance, this is equatable to between 37 and £40,000 worth of potential air leaks. This highlights that energy costs are the biggest factor over its life, and that air leak remedials are a quick and sensible solution to reduce this. As a quick example of this, a food production factory in Yorkshire recorded a £217,000 survey in March this year and signed off on a £200,000 cost saving after taking into account the labour time and spares required to repair. So for the typical start to finish routine, we are asked to go to site to discuss an air leak survey. Once on site, we ask typical but important questions about your compressors and general air systems. We also walk around to scope up the time it will take to perform. We detect the leaks with state-of-the-art leak shooters, which visualize the leak and record the amplitude. The image is also used in the report for evidence. We record the details of the leak on our own software, which has been designed around customer requirements to give you reports that give you relevant and accurate information. We also tag the leaks with metal detectable tags where possible, which means finding them to remedy is made easy for you. For ATEX required sites, we are able to use equipment that is safe on site. It does mean, however, no pictures can be taken, but the data recorded is just as accurate otherwise. Also to highlight, our surveys are also COVID friendly. The way the surveys are conducted means we rarely require to be in contact with people or to touch your equipment. Just on screen are a few example pages of the report that we can generate. The survey can also provide remedial parts lists, estimated time to repair, and also if required, we are able to facilitate the repairs ourselves. The report also breaks down each area, so you can identify critical points or prioritise where to concentrate remedial fixes first. We also are able to log the CO2 emissions created powering these leaks, which if used to fix, helps with obtaining your ISO 50001 accreditation for energy efficiency. So moving on to hydraulic oil cleanliness. So with our hydraulic centres, we are now able to offer you contamination control on your hydraulic systems. The concept of this works similar to the other CBM technologies we've mentioned. We install a particle counter onto your running power pack, which checks constantly over 10 to 15 minutes the status of your hydraulic oil, logging particle counts and other information. We then present to you this information and talk you through what this means and what remedial action you may need to take. It is a sealed system, meaning the data taken isn't affected by outside contaminants and works whilst your equipment is running, so there is no downtime, is simple and quick to fit, and allows you to see live data concerning your equipment. If action is required, either an oil change may be suitable or a simple flushing rig may allow us to filter the oil to bring it back up to the correct standard. The flushing rig works by creating a closed circuit in your hydraulic system and forces the oil around turbulently at high pressure, picking up debris and contaminants where the high-end filtration system then filters out. The unit also contains a particulate sensor and so continues to filter until the sensor indicates that the contamination level has reduced to a preset acceptable standard. Different size rigs are available. The usual high time is around about 5 days as an average, but we can discuss your requirements, visit your site and quote on your needs appropriately.
So further to the oil cleanliness side, within the PCMEng Group, we also have our own commercial oil laboratory, as you may have seen on the previous slides. So lubricant analysis really is looking at monitoring the health not only of the oil but also of the asset itself, and that's one of the key differentials from our perspective. So we're a complete independent oil laboratory. We're not involved with any oil suppliers or manufacturers, so there's no conflict of interest from that perspective. So where our reports are providing a third-party view, we're really looking at those assets to ensure that that oil is fit for purpose. It's not just about a procurement exercise. It's not related to cost. If the oil is not fit for purpose, the reports will tell you that it's not fit for purpose. But essentially with the oil and grease testing, so we look at oils from gearboxes, white metal bearings, from hydraulic systems. We also test used grease samples as well to look for any contaminants that exist within grease as well. Really, we're looking at the lifeblood of that machine. So you may have heard that terminology before. It's the same as going for a blood sample at the doctor's surgery in effect. So it gives us a great insight to the running conditions of the asset as well as the condition of the lubricant that exists within. So when we're collecting an oil sample, whether we're performing the oil sampling or whether we're providing the kits for your guys and your reliability teams on site to complete the sampling, we provide everything that's required. So it's the syringe, it's the vampire pump, the pipe work, the bottles, the labels, which could be pre-printed with predetermined assets information. But as usual, I mentioned earlier on with the crap in, crap out scenario, the more information that can be provided with any sample or data collection technique really does provide key information to improve the accuracy of any analysis. Now, we do advise that any samples are taken just after shutdown or during the operation of the unit, if that's possible from a safety perspective, from the middle of the main body of oil. The reason for that is to get the particles in suspension, so there's a good dispersion of particles within there, so it's representative. Drain points are not really recommended because they tend to have contaminants, dirt, water within there, so you can get false positives or false negatives within the asset condition, which there's risks from both sides from that perspective as well. Once the samples are back in our laboratory, we turn those results around within 3 working days, and that's the standard that we operate to. The testing suites, if you use another laboratory for oil analysis, the test suites will be very, very similar. They're all ISO and ASTM standards that are used. So from that perspective, with the potential failure modes that exist on a lot of our critical assets, can we really afford not to have that understanding for what is essentially quite a low cost per sample, the oil sample analysis and the kit that you can collect the sample with. So as long as the sample technique is correct, then obviously we get some good information from that failures. We currently process around 50,000 samples per year in our laboratory from multiple clients globally. Our staff are ISO and PCM trained to lubricant analysis level 1 or level 2. But it's also backed by engineering knowledge as well. So yes, we have chemists. We also have a team of engineers that back up the laboratory as well, so that the output from our reports, as I said earlier on, would never be there's just an increase in copper. It would actually give an indication on where is that copper coming from. We would delve into understanding the asset, where that contaminant or where indices could be coming from. So we have all our reports that are posted on our cloud-based asset insight tool, which is Amiga, which is available 24/7, doesn't require any IT software installation. It's on a HTTPS secure system as well on a website. So from that perspective, it also encompasses information from vibration analysis, oil analysis, thermography, any of the techniques applied in CBM, and also any inspection techniques as well that we collect during our standard routines. So really it pulls all the pieces of that jigsaw together to give it all on one view. It's license free, any logins as required from that perspective, which is a big benefit. So from that perspective, ASTM and ISO standards allow us to accurately classify the health of that machine. Now, that also, ISO standards are one review of those alarm limits to assess those criteria within those samples. We also have thousands and thousands worth of data samples from various different industries where perhaps the same gearbox or unit is operated, but it's in a slightly different application. Statistical analysis is one of the key areas for development of these assessment criterias. But wherever there is an OEM requirement, or if you have your own on-site standard for those requirements, then obviously we can build that within the system as well, so it's specific to your needs. We've also recently introduced turbine oil sample testing as well within the laboratory, which is quite a specialist piece of equipment as well for looking at the remaining life expectancy of oil samples. So when you're looking at the outputs of the oil reports, typically split into a trivector, which by definition has 3 sides. So we're looking at the wear elements, the contamination index, and the chemistry. When we're looking at the chemistry, for example, we're looking at additive packages, the level of viscosity, the general lubricant performance, is it still fit for purpose, is it showing signs of oxidization, and so on. At this instance, we may actually compare that with what is termed as a virgin sample or a barrel sample to understand what the oil was at the outset when it was in the barrel before it went into the asset itself. By performing that check, we can directly compare against what it should be compared to what has come out of the unit itself. And that opens up a window of opportunity to understand, is it past the end of its useful life? Is there an issue with dilution of some other oil type within there where perhaps the lubrication management standards are not up to scratch on site? So there's various elements within that chemistry arm that provide that required information. Contamination, so this could be internally generated, or it could be generated during the sampling itself if the sampling is not done to the correct standard. But it could also be abrasive dirt that's got into the system due to a seal failure. It could be water, could be fuel dilution within an engine or a piston ring problem, and so on. And down to the wear indices, where we're looking at specific particular elements within there that show friction, abrasion, and erosion particles where surfaces are moving together, or it could be from corrosion as well if moisture exists within the system. And we look at the size, the shape, the material of the part. Yes, it's wearing, but how is it wearing? What is causing the problem? So from an oil analysis perspective, we regard our services as it's a managed service. We do carry out on multiple different assets. Our oil analysis service is not just about the oil condition, it's about the asset condition. As I've mentioned, we've got the analysis. We're also a BIND accredited organisation to deliver training to BINDT Category 1 and Category 2 for lubricant analysis. And obviously, I've mentioned the cloud platform as well. Very briefly on a case history, which is a bit of a strange one. It's not always just about used oil analysis. This is an example of an oil hydraulic system where the filters were continuously blocking up with no specific explanation as to why. So we were basically sent the entire tank, which was amazing and quite interesting. So through microscopic analysis, we determined that it was non-ferrous particulates that were in dispersion within the oil. We actually went about to take what were termed as core samples. So we took a hole cutter, for want of a better description, with various tests with different oil types, different temperatures, different pressures, to determine what could be happening within that particular system. And what was actually found was through various, almost like a perfect storm, through various temperatures and pressures, the tank itself was actually starting to delaminate. So that was the particulate that was going into circulation within the system. So we determined that actually there was a lack of a filter line, a tank liner within the system that was actually the ultimate root cause of the problem. So very strange one. So it's not always just about rotating assets on gearboxes and so on. Jason.
Thank you. So moving on to thermography. Thermography is the inspection of abnormal thermal levels and patterns emitted by an object. As with vibration analysis, if we do this over time, we can trend the information to spot anomalies. We can also use this to do one-off checks, i.e. electrical panel thermography or silo tank level checks. Either readings outside of ISO standards or spot readings that differentiate from other sensors. Again, as an example, tank levels. Using state-of-the-art equipment along with experienced and qualified engineers, we are able to advise of potential faults as well as providing the service to rectify where possible. Thermography can be used across a wide variety of applications, including refractory kiln testing, transformers, building insulation and energy loss, solar panel functionality, and steam traps, as well as the following. Electrical panels. Thermography is the only preventative maintenance technology that is effective for identifying problems with poor connections, overloaded cables, and faulty electrical equipment safely, and without any disruption to the normal operation of your business. Moisture detection. Mold and moisture can cause extensive damage to buildings and health problems for tenants, so we are able to offer thermography as part of building inspections. Motor and gearbox inspections. The extra load on a bearing caused by misalignment will often cause increased temperature at the bearing, which can be seen with thermography. Bearing wear and over lubrication will also cause a significant increase in temperature. And finally, pipe insulation lagging. Thermography allows the user to find lagging defects and leaks in long pipelines. Our reports are clear, concise, and advise recommendations to remedy the issue using the latest reporting software. The lubrication. So for your lubrication needs and requirements, our team can provide the relevant goods and services to keep your equipment lubricated correctly. As Antony mentioned previously, the consequences of poor or inadequate lubrication usually entail higher maintenance costs, increased time, and even higher chances of work accidents. By lubricating equipment at the right time with the right amount, your equipment lasts longer, reduces the need to service, and increases machine performance. We can offer solutions, as you can see on screen, from single-point lubricators all the way to full modular systems, from 15mm lubricator pots right the way up to 8-litre tubs on an auto lube system. Brammer can cater for all budgets and requests, and we can even install in sections, helping to reduce the cost along the way. Just a couple of examples of who we work with, a few examples. First one being Kerry Foods Hartlepool. Now this started out as a small inquiry and has now turned into 2 days on site with condition monitoring. We have found issues and breakdowns have been prevented. It has also led to an insight being implemented there, such was the quality of the work. At Coca-Cola, our state-of-the-art air leak survey system, along with the latest equipment and trained engineers, means we now have the contract to conduct not only all of the UK's air leak surveys, but the repairs to rectify as well. And Ibstock as a group, we have gone from working on 2 sites to being engaged with 8 sites and working monthly regularly, 5 in the space of a year. And this is set to expand over the year to more sites. So what happens next? So, moving forward over the coming days, our local teams will be in touch anyway to discuss the presentation for feedback if there's anything of particular relevance that could help prevent downtime within your site's factory. Once you've had the initial conversation with the local teams, our field service engineers and, if required, PCMS will happily visit your site to look at any challenging applications with the aim of offering solutions.